In this video, we are going to create a script that computes the Jacobian matrix and Hessian matrix of a function for a specific solution of that function. And we are going to compare our results from DIgSILENT with the results from Matlab for the Jacobian and Hessian for the same function and the same solution. First, let's see how a Jacobian matrix looks like. As you can see, Jacobian matrix is just a matrix filled with all the first order partial derivative of the function with respect to the state variables. The same for the Hessian matrix is a square matrix that comprises all the second order partial derivative of the function with respect to the state variables. Okay, now let's see the script. As you can see, the script has as an input has two inputs. First is the test function number, and the second is the number of state variables. So let's see here in content, we have a script that have some test function. The first test function is the Numerical. Numerical is a test function that has 4 global minima for which the function has the value 0. We are going to, for our demonstration, we are going to take the first solution, 3 and 2. Yes. Okay, but first let's see how we obtain the derivatives for the Jacobian, for the Jacobian and for the Hessian. Okay, so we are going to use the forward differences. Here, actually, we are going to use this formula here. So limit of h tends to 0, fa plus h minus f of a divided by h being a very, very small number. Yes, so this formula is used to compute the derivatives. Let's see. Okay, so inside the script, we have the formula over here for the Jacobian. Is exactly, one more time, it's exactly like the one from here, but the notations are different. Here we have f0, which is fa plus h. Here we have f, which is f of a, and here we have f's, which is h. F's is being a very small number. Yes, we call the perturbation. Yes. Okay. So first, the script computes f. Okay, f is the value of the test function for the initial solution. So for the input. Of course, the user, I forgot to mention, the user wants to introduce the solution. So the solution is going to be, as we mentioned earlier, 3 and 2, yes, for the state variables, 3 and 2. So f is going to be the value of the test function computed for the initial solution, for the 3 and 2, yes. So we computed this term. Then we are going to compute f0. f0 is going to be computed as follows. So in matrix x0, we are going to copy the input matrix with 3 and 2, but in this loop, we are going to introduce the perturbation. Yes, as you can see, for the ith term, we introduce the value of the input plus the epsilon plus the perturbation, and then we are going to compute f0. Having computed f0 and f, knowing f's, so for the ith term, we already have the derivative value. Yes, let's put a breakpoint for the and to see the first how it is computed, the first term of the Jacobian. Yes, so execute. As I mentioned earlier, for the Numerical function and for the solution 3 and 2, we have the objective the function equal with 0. Okay, go in content and see the input is going to be 3 and 2. As I showed earlier, the x0 for the first term is going to be exactly the input 3 and 2, but with the first term added the perturbation. So it's going to be it's not going to be 3, it's going to be 3.000001. Yeah? Okay, and the first term of the Jacobian according to the formula is 0.000037. Yes? Okay, we are going to remove this breakpoint and we are going to compute the Jacobian. Execute. As you can see, here is computed and printed the Jacobian 0 and 0. Also, the speed computed and computed the Hessian 74, 20, 20, 34. Okay. Now let's see how the Hessian is computed. So we are going to use the same equation, but it's the second order derivative. So the equation will look like this. We are going to put a breakpoint, and now we are going to look at each solution for f, f0, f1, and f2 to see how the perturbation is added. So x0, x1, and x2. Yes. For f, we have the input. So we put a breakpoint here at the first term. Execute. Okay. Let's go back. For f, we have the input. Here, 3 and 2. For f0, we have x0, which has the first term, which has the perturbation added. For f1, we have x1. We see here also at the first term we have added the perturbation. And for f2, we have x2, in which it has added 2 times the perturbation with the first term. And we are going to see having all these terms computed, f's and f's. So the first term of the Hessian is like this. Sorry. Is 74.00007. Yes. Now removing this breakpoint. Once again, we obtain these results. Okay. Now we have now that we have the Jacobian matrix and the Hessian matrix and DIgSILENT with our script, let's see the same the results from Matlab for the same function and for the same solution. Yes. We have here implemented the Numerical function in Matlab, the solution. Here we have the Jacobian and Hessian script dedicated from Matlab that computes the Jacobian and Hessian. So run. As you can see, in Matlab we obtain 0 and 0, the same value as us, as we obtain. Of course, if we use a smaller perturbation in our case, we would obtain the values closer and closer to 0, like they obtain here. And the same for the Hessian matrix, 74, 20, 20, 34. We obtain relatively the same results, with the mention that if we use smaller perturbation, we would obtain value closer, like the Hessian matrix from Matlab. Further, we are going to choose another function to compute the Jacobian and Hessian. So in our script, we're going to go in test function and write here 8. So we are going to choose the 8 test function and choose let's say 5 state variables in content, and see the 8th test function is Stiblinsky tongue function. Okay, but because we choose 5 state variables, so we are going to put here also 5 values. So we're going to 1, 2, 3, sorry, 1, 2, -1, 3, and 1. Yep. I choose them randomly. Okay, but okay. Now we are going to compute the Jacobian and Hessian matrix. Okay, so these are the values: minus 11.5, minus 13.49, so on and so forth. Now let's do the same thing in Matlab. First, let's comment this part and uncomment this part. Okay, we are going to use the same solution, but let's see what the solution is. 1, 2, -1, 3 and 1, 3 and 1. Okay, that's it. Now execute the script. This, you can see the results are identical with ours. As you can see, the minus 11.5, minus 13.5, 16.5, 8.5, and minus 11.5. The same for the Hessian matrix. Minus 10, 8, minus 10, 38, and minus 10. I will mention once again that the results are going to be much closer with the one from Matlab if you are going to, if the epsilon is going to be smaller and smaller. Okay, thank you so much.